Beneath this continent of ice, time operates on a different scale. Here, 1,000,000 years is a mere geological breath. The ice does not simply cover the land. It seals it, preserves it, forbids it. For decades, radar and satellite data have sketched the ghostly outlines of what lies below. Mountain ranges rivaling the Alps buried under 2 miles of solid ice. Networks of rivers that defy gravity, flowing uphill under immense pressure. And over 400 subglacial lakes, isolated, dark, and ancient. These are not mere puddles. They are capsules, isolated from the atmosphere, from sunlight, from the surface world, for up to 15 million years. To penetrate one is to open a door to a pre-glacial past. The target was not a lake, but a cavity, the Dotson Ice Shelf. In 2022, an international team launched a probe named RAN, a 20-foot autonomous submarine designed to go where humans cannot. Its mission was to map the underside of the ice, to understand the melt tearing at the continent's seams. For 27 days, RAN navigated over 600 miles in total darkness, its sonar painting the first high-resolution images of this inverted world. What it found was not a smooth, monolithic ceiling. It was a landscape. Carved into the ice were teardrop formations, soaring plateaus, and intricate channels of erosion, patterns so complex they defy current models of glacial melt. The ice itself was a geologic record, and it told a story of turbulent, warm water acting in ways we do not yet comprehend. But the mission carried a risk. In this realm, there is no GPS, no communication once the vehicle submerges. The team could only program its path and wait. In 2024, when they returned to continue their work, RAN did not emerge at the rendezvous point. It vanished. The official report suggests it ran aground or encountered an obstacle, but the loss was profound. RAN was more than a machine. It was a pioneer. Its final transmission, however, contained a data point that did not fit any glacial model. A thermal anomaly, slight but persistent, localized not in the water column, but within the bedrock wall of the subglacial cavity itself. This anomaly led a separate geophysical team to a different part of the coast the following season. Using ground-penetrating radar on the surface, they pinpointed a vast, air-filled void within a coastal mountain range, its entrance seamlessly glaciated over. Not a lake, a cave, a system of caves, sealed by ice for a time span measured in epochs. The effort to reach it was a feat of engineering in itself. Thermal drills melted through half a mile of ice over the entrance. When the drill head finally broke through, it reported a drop, an emptiness, and a sudden dramatic spike in atmospheric gases, oxygen levels far above the Antarctic norm, and traces of methane. This was the hook. The cave was not a dead space, it was breathing. What defines an extreme environment? Scientifically, it is a condition far outside the normal range for complex life. For microbes, known as extremophiles, these places are home. They achieve this through strategies that seem to pause life itself. Metabolic slowdown, a state of near-perfect dormancy. They produce specialized enzymes that function in bitter cold and proteins that act as biological antifreeze, preventing lethal ice crystals from forming within their cells. In the subglacial lakes of Antarctica, such life has been confirmed. Methanogens that create methane for energy, methanotrophs that consume it, entire microbial food webs based on chemical reactions surviving on the mineral nutrients scoured from pulverized bedrock. Life finds a way, but it is a slow, patient microbial way. When the team finally lowered sensors and lights into the sealed cave, the first images were of stunning, sterile beauty. Walls of smooth, water-carved stone, mineral formations unlike any seen in surface caves, delicate, lace-like structures of pure white. And then the cameras found the water, a perfectly still black pool at the cavern's base, fed by a trickle from a rock fissure. It was not frozen. The ambient air temperature was a shocking minus 1.5 degrees Celsius. The water, according to spectral analysis, was just above freezing, but surrounding it and covering much of the cavern floor in a strange mat-like texture was a thick layer of biological material. It was not microbial. The initial DNA sequencer fed a sample gathered by a sterile robotic arm identified complex multicellular organisms. The genetic markers were unfamiliar, but the phylum was clear: Annelida, segmented worms. But these were no ordinary worms. Preliminary size estimates from the video put the largest tubes at over 1.5 feet in length. They resembled, in bizarre form, the giant tube worms found around deep-sea hydrothermal vents, creatures that thrive in total darkness fueled by chemosynthesis. Here lies the profound, unsettling paradox. Hydrothermal vents are powered by volcanic heat and rich chemical soups. This cave is a frozen closet. The energy source is a mystery. The temperature should prohibit this scale of life. Yet, the evidence is in the water. Analysis showed the pool was rich in hydrogen sulfide and methane, the very fuels for chemosynthetic life. The leading theory is a geological one, that the cave connects to a deep subsurface aquifer where ancient organic deposits under pressure and isolated from oxygen have undergone slow geologic digestion. This would create a steady, infinitesimally slow seep of energy-rich chemicals. Not a violent vent, but a whisper, a drip feed of fuel over millions of years. In such a setting, evolution is not driven by competition, but by conservation. Every biochemical process would be optimized for staggering efficiency. Life would not rush, it would endure. The organisms here would have had one imperative: to survive on almost nothing for almost forever. The discovery of complex stationary life rewrites the rules of the cave. It suggests not just a habitat, but an ecosystem, and every ecosystem has inhabitants, consumers, scavengers. The robotic lights began to sweep the darker recesses of the cavern beyond the primary pool. It was there they saw the first sign of movement. Something detached from a shadowed ledge and drifted slowly, languidly through the beam of light. It was small, no larger than a human hand. Its body was translucent, revealing a faint internal bioluminescence, a pale blue-green glow that pulsed once, slowly, like a dormant heartbeat. It did not flee. It simply moved with an otherworldly grace back into the darkness. The scientists had prepared for microbes. They had theorized about ancient water. They were not prepared for this. A motile, complex, and seemingly placid animal living in perpetual cold and darkness in a cave sealed before the dawn of humanity. The sealed cave was not a tomb. It was a sanctuary, and they had just turned on the lights. And in the next section, we will learn how a world sealed in ice for millions of years continued to survive, without light, without warmth, and without ever knowing the surface existed.